Go. I pushed the red.
Okay, Cindy Shelton, I would like to work with you on section 3.2 of your applied math homework. The topic is truth tables, and I wanted to show you first of all some of the rules we'll need to use to make a truth table. Our symbolic language, we have this symbol, kind of an inverted V, which means and. We call that a conjunction. And whenever we're evaluating the truth value of an and statement, you have to have both true in order to assign it a true. So T equals T. If you have an FT, you say F. So both true to be true in a conjunction. The V is the or statement. It's called a disjunction. And when you're evaluating the truth value of it, only one of the values has to have a T. As long as you have one T, you assign it a true. The next symbol is the arrow, is the if-then statement. It's called a conditional, and it will be true. You'll assign a T in every case except when the first value is true and the second one is false. So if a P is true, if you have a TF equals F. So TF is the only case in the conditional that equals an F. Everything else is true. The double arrows is an if and only if statement. We call that a biconditional. And it is true only when P and Q, the two values, have the same truth value. So you can actually have an F and an F, and you'll call that true. Or a T and a T obviously is true. But they have the same value, you say true, otherwise false. So those are kind of our rules of our game. And in the squiggle line means negation, doing the opposite of what the statement says. Okay, so we'll refer back to this. This is the foundation of all that we do in this chapter. First question in your homework will be something like this. You know, it regenerates, so they're not all exactly the same as this, but should be similar. Question 1 says, construct a truth table for the given statement. The statement is Q and not Q. So you'll notice on Math Excel that they've already drawn the box, and they've got a Q label over that. Okay, there's only one statement here, just statement Q and then the negation of Q, but not two different variables. So we only have the variable Q to account for. There's only two possible truth values for Q. It can either be true or false. So that's imprinted into your chart. Then in the next column, it says now assign what not Q would be. When it does this, that just means look over here and write the opposite. So F will change to T. Then the next column says to do the whole sentence, the compound statement, Q and not Q. Now for what we said over there, if you have the inverted V, and means that they have to both be a true before you say true. So we have a true and a false, so that's not true. And we have a false and a true, so that's not true. Remember, they have to both be true before you say true in an and statement. Okay, number 2. Again, this time we have a P and a Q. So I really, the hope with the video is to try to explain to you why that chart is already started as it is and where that came from. So there's two different statements. There's a P and a Q variable. And in your chart, you'll see they've already written down some F's and T's. And that's just the different possibilities for two statements. They can both be true. One can be true and the other false. The first one false and the second one true, or they're both false. So that's not any algebra to that. I guess it's just those are the possible combinations for two statements. Both true, both false, or one of each in different orders. So the different combinations for those. So that's already in your chart. Then the next thing in your chart says write down a list of what not P would look like. Not P just means look at your P values and do the opposite. So fill in opposite values in your chart. And then the compound statement would be figure out what not P or Q's truth values would be. Referring back to what you've already filled in, focusing on not P, this column, and the Q column. So just looking at these two columns, and notice it's the V, so that means or. Remember the rule for or says as long as either one of these is true, we'll put a T. So T and F would be T, F and F. That's not true. T and T is okay, and F and T is okay. And then that fills in your truth table. Okay, number 3. Number 3 is still the same idea, only it's more wordy. They've expressed what statement P is standing for, and the other two, they just called it a variable and evaluating it as the statement. So this time we have a statement P, the cheese has been sliced, and statement Q, the dishes have been set. And we're supposed to make a truth table for this statement, or compound statement. The cheese has been sliced, that was statement P, and we make the symbol like that. The dishes have been set, that's the second statement, just as it was. Nothing was negated, just plain as they were written. So make a truth table. Notice they already have the P and the Q in your table and the 4 possibilities for 2 variables. Both true, 1 true, false, false and true, false, false. That's a given. I think in all of your homework problems. Then we evaluate the compound statement of P and Q. Remember, for and to be true, they have to both be true. So true, true is true, true, false, 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 true is false, and false, false is false. I think that's all you did there. Number 3. Okay, number 4. Can you see this okay? Number 4, a little longer even, you've got 3 statements to evaluate. So we're going to extend what we've learned here with 3 variables. So we've got the 3 statements we're going to represent with P, Q, and R. Statement P is I go to office hours. Statement Q, I ask questions. And statement R, my professor remembers me. Remember, a simple statement just conveys one idea. So those are 3 simple statements. All right, so we need to write out symbolic language for this sentence. I go to office hours. That was statement P. Or ask questions. Remember, or is a B, and I ask questions is statement Q. Notice then we have this comma. So we're going to have more complicated with the 3 parts. Usually when you see the comma separate, there's a parenthesis around those 2 ideas. Then it says the word and, which is the inverted V, and my professor does not remember me. Now notice we made statement R represented by my professor remembers me. So this has negated it. So we need to say negation of R. So you pick that choice. Then it says to make a truth table for that. Now notice the truth table has grown because of the 3 statements P, Q, and R. And again, I really want you to see where they have filled in the part of your chart that's already there. And if you would have a problem where you had to do that on your own, it's just writing out all the possibilities of combinations. Either all 3 are true, we've got true, true, false, true, false, false, all false. Let me try to get them in the order they are in your paper. True, 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 false. I didn't write it exactly the way they have, although really the order doesn't matter as long as you get all the possibilities in. T, and bear with me for just a minute. But from my notes, I think your problems have this done for you. Okay, then we go step by step. It says in the next one you need to evaluate this part, the first part of our problem, P or Q. So we look over here at the P and Q columns, and remember to do an or evaluation. Either one can be true. So a TT is T. As long as one of these are true, we say true. Here's a false, false, and a false, false. So that's how we get the P or Q column. Then the next column is the not R column. So we just focus on the R column and negating that. So opposite all of that. Okay. Then the last column is the whole thing, the whole compound statement. Put that together, and that was P or Q. Evaluating that column with an and, not R. So to assign a truth value to that last column, we're looking at the P or Q column, so we focus on this column and the not R column, this column. So these 2 just happen to be side by side, that's nice. And we're evaluating for the last part of the order there, which is the and. Now remember, for an and to get true, you have to have 2 truths. So they have to both be true to get a T. So T and F, F, TT, that's that's true. TF, false. There's a true, true, which is true, false, true, false, and false. So they would both be true. Okay, so I'll stop it there. That concludes 3.2.